So okay, two or more atoms. So it could be O2, it could be NaCl, right? Sodium chloride, table salt. It could be H2O. It could be CO2. It could be H2O2. Okay, that's enough. But here's the thing: they're chemically combined. They're not just next to each other, right? It's not just like pen caps and pen lids. They're just sort of next to each other. It's like they're chemically combined. I can't just pull them apart. Okay? I can't just pull them apart because I have to use either another chemical or electricity or something really strong to get them to come apart. Like H2O, I can't just pick oxygen and hydrogen atoms apart and turn water into hydrogen gas and oxygen gas. I have to use electricity. Anybody see that in IPS class? The Hoffman apparatus, big glass thing with electricity goes through it, and it makes the gas appear on either side. That's how you separate chemicals. So
yeah, and then you capture it, you test tube, and then you put a match to it, and it goes ding.
Right, it goes boom. Right, exactly. Okay, so two or more atoms, sometimes different elements, sometimes not, chemically combined. You can't just pull them apart, and in a fixed ratio. That means a certain number of each, always. Like, look at this. This is H2O. This is water. You drink it. You keep alive with it. This is hydrogen peroxide. There's only, look, this means, by the way, 2 hydrogens, 1 oxygen. If there's not a number here, it always means 1. It's like a silent 1. Okay? And so this is H2O1. This is H2O2. Now, this you can drink to stay alive. You can wash down your lunch with it or whatever. This, you put it on cuts, and it'll kill bacteria and stuff. But you don't want to try to stay alive by drinking this. You will not stay alive by drinking this. In fact, the opposite will happen. You won't last very long drinking a nice frosty glass of hydrogen peroxide every morning. So, fixed ratio. CO2, 1 carbon, 2 oxygens, right? What's the other thing with carbon and oxygen? CO, carbon monoxide. One of these you breathe out and it's not really a poison. One of these, carbon monoxide, if your house fills up with it, you need to get medical help or you could die. That's why you never burn a wood stove, or you never burn your barbecue inside to keep your house warm. You all those sorts of things, and you always want to tune up your furnace so that it's not emitting carbon monoxide. Bless you. Here. You're welcome. So, all right, over here we've got fixed ratio, chemically combined 2 or more atoms. So that's it. And then mixtures. You don't have to know much about mixtures. Mixtures is everything else. Everything else. Mixtures are basically 2 or more substances, meaning pure substances, in no particular order or ratio. So you can have like hydrogen and oxygen gas mixed together, but that's not a chemical compound until you give it some spark and turn it into water.
In water.
Right. Yeah. That's like that's all there is I want to say about that. Like oil and vinegar, they're separate from each other. They're not together chemically combined. Okay. So take a minute, make sure you got the rest of that. There's only one more thing. I'm going to erase this one more time. I'm going to fill it about halfway up, and then I'll give you guys a couple practice problems to do. And that's how we're going to finish today. Okay? Not too much more. All right, oh, thank you. Okay. We all good? Okay. What?
Yeah.
Yeah, okay. I'm erasing this. Okay. Two other things. 1. Wait, up here. Am I still on screen?
Right there.
Counting atoms and molecules. Yeah? Like, for example, basically what we're focusing on tomorrow is a few specific substances. And this one really looks like a humdinger.
Isn't that sugar?
It is, yeah, this is sugar. This is glucose, actually, which is sugar. And what I want you all to be able to do is to see how many of each kind of atom. Because when you look at a chemical formula, what it's telling you is that in this compound, glucose, there's a certain number of each kind of atom. And if you look at the periodic table, you can identify them. Like letter C is up here, that's carbon. H is over here, that's hydrogen. And O is over there, and that's oxygen. Okay, without going into it too much, this is sugar, and what you do is that each number or subscript relates to the atom, the element just to its left. And so if we were going to count how many of these there are, you always do it like this. Like think of H2O. H2O means 2 hydrogen, 1 oxygen. That's what that means. And so if you ever get confused, use that as the example, because most people remember H2O is 2 hydrogens and 1 oxygen. And remember, if there's no number, it's a silent 1. That's sort of chemistry shorthand. But, all right, so carbon C6, and so it's the 6 that applies there, and so, right, 6 carbons. Hydrogen, H12, right, and so that's 12 hydrogen, oxygen, O6. 6 oxygen. And that's basically what I need you to do with that. And then one quick other thing. I thought I was going to be able to do these both on the same board, but go ahead and write that down. We'll practice this in a little bit. Hey Braden, William's handing you the case. Ah, there it is. Missing a cap. Yes, sir.
So there's 6 atoms of carbon.
That's right.
12
That's
atoms.
right. I should write that. 6 carbon atoms, 12 hydrogen atoms. No, thank you. And so that's the number of each kind of atom in here. All right. So in one molecule of glucose, you would have all of these. Okay, so I'm going to move on, okay? Can I erase this?
Oh, hold on.
Am I going too fast? No, I am going too fast, okay. It's fine. We got Ready, Gabe?
Yeah.
Okay. Alright, I'm erasing this. Last thing, folks. Sometimes one thing changes into another thing. And in order to understand that, we write a chemical reaction. Chemical reaction is when you have reactants become product. Chemical reaction describes a chemical change. Or rearrangement of atoms and compounds. Describes a chemical change, a rearrangement of atoms and compounds. In a chemical reaction, you start with the reactants, which are your beginning compounds. This arrow is sort of like the equal sign, and it means yields or becomes. So it's kind of like this becomes products, which are the ending compounds. Okay, for the very last thing, I'm going to give you an example of a chemical reaction. Okay, and you can make sure to get it all down. And so, you guys are doing great today, by the way. An example: iron metal, Fe. Fe stands for ferrum. It's the Latin word for iron. Don't worry too much about it, but it's true. What happens to iron? Yeah.
Doesn't it break apart?
Why?
Because it's radioactive.
Nope, that's something you're thinking of uranium. Iron has this irritating tendency to combine with oxygen in the air if there's a little bit of moisture, and it turns into rust. Right? Iron rusts. You get that reddish corrosion on anything made of iron. I don't have anything rusty right here, or I'd show you, but it's happening a little bit here. You can see it's kind of getting a little bit rusty here. But the chemical reaction for that is that iron and oxygen combine to form a new compound, Fe2O3. So that's an example of a chemical reaction. So we're not learning super deep chemistry in here, but we're learning, just the basics. Like if you see a plus between these, it means they're two separate things. When you see this written like this, it's become one compound. So this is basically iron plus oxygen yields or becomes rust or iron oxide. Okay, so just take time to write that.
Oxygen, O2.
Right. Well, it is O2 when it's by itself, but there's in other compounds it could be a lot of different things. Like lead oxide is Pb2O5. And so it just depends on the compound. It'll take different amounts.
So it's still oxygen.
It's still oxygen, but now it's in a compound. Like you can't breathe this. You know what I mean? So it's like a totally different form of oxygen, and you can't build bridges with this either because it's rust.
Yeah.
This you can build bridges with. This you can breathe. But when you put them together, what often happens is that the substances change properties completely. You can't do the same things you could originally.